Okay. Cool. Right. I'll allow you the permission to chat. So let's, without any further delay, let's talk about linked lists, because I'm assuming that whatever doubts you might be having, still some idea you would have gotten in the past 2 days, in the past two lectures, you would have understood something about the linked list. Okay, how to implement that and everything, we will cover it again today. But I expect that some basic idea is clear to you about what a linked list is, right? So just to cover that again, before I move on and start explaining the implementation, all of us know what an array is, right? Array is also a data structure, right? Array. The main point about an array is it looks, we represent it something like this, right? For example, if I want to store 5 integers, this is generally how I will kind of represent my array, right? So let's say 1, 2, 8, 4, 9. So this is my array of size 5, and it has 5 integers stored inside it, right? So how would you be declaring it? Something like this: integer array is equal to new integer, sorry, and then in bracket you would maybe write the size of it, right? And then you can say array of 0 is equal to 1, and so on and so forth. You can keep saying array of 4 is equal to what? 9, right? Is equal to 9. So this way you used to declare your array, write the values inside that. This is how you used to cover the arrays, right? One main point that I want you to understand from arrays is, in your array, these items, all these integers, were stored side by side. Okay, what I mean by saying side by side is, inside the memory, let's say, just for explanation point of view, I'm using these terms. Okay, these are not the actual terms. So let's say the address inside the memory for our first element is M1000. I'm just randomly naming it. In general, it is a little bit more complex, some X, L, R, whatever, some you can say confusing words. But just for simplicity, I'm saying that this is the memory address where your first integer is stored. So what I now want to tell you is, if this is the memory where your first integer is stored, the next integer will be stored just side by side to this particular memory block. Okay, so the idea is your integer takes 4 bytes. Okay, your integer takes 4 bytes. So if I start from M1000, what does it mean? 1000, 1001, sorry, 1001, not 10,001, 1002 and 1003. These 4 bytes, so I'm just making assumptions, okay, just to make you understand. These 4 bytes, I'm assuming all these spaces represent 1 byte. Okay, so 1000 represent 1 byte, 1001 location is another byte. So that way, 1000 to 1003, these 4 bytes are reserved for your first integer. So what I mean by saying that the next integer is going to be just next to it, what do I mean by saying that? The next integer will start from a memory location something like this, M1004, right? So next to these 4 bytes that are reserved, just next to it, the next 4 bytes will be reserved for the next integer. Okay, so this is your first integer, which is indexed as 0, right? Array of 0. This is your second integer, so on and so forth. You will keep doing this. So the third integer will be like M1008, M1012, and then memory location 1016, something like this. Your numbers would be stored, right? So contiguous memory allocation, as Vibhuti is mentioning, so that is what happens inside the array, right? Continuously you want to store it, but you can say, just to give a very crude intuition to you, a very basic intuition, in array there are 2-3 limitations. Okay, first is you have a fixed size. First limitation. Second is you reserve contiguous blocks of memory, right? So you reserve contiguous, or you can say continuous blocks of memory. The problem is, let's say you want to store 10,000 integers. So it's not that you want 10,000 into 4, that is 40,000 bytes. It's not that you just want 40,000 bytes. The constraint here is You want a block of 40,000 bytes, right? It will not work for you if you get 400 bytes here and 400 bytes there and like that. In an array, it will not work like this. You want a complete block of 40,000 bytes. That's not always possible, now that you get such a large block of memory in a contiguous manner. That's also one limitation. Third limitation that you can say, so I'm just picking these limitations randomly, okay? And if you read from the internet also, these plus minus 1 2 problems you will find for arrays, like maybe some more problems you will find about array, but I'm just covering the basic issues with array, right? It has a fixed size. You have to reserve contiguous blocks of memory. That's a constraint, right? When you want to store bigger chunk of data. Third problem is you don't have the functionality of deleting the elements, or you can say adding the elements in between or something. So my point is, because array has a fixed size, you can't really delete a particular block at any point of time, right? What you can do is, आप ऐसा कर सकते हो कि if you have 9 stored here, maybe what you can do, just to represent that this place is empty, you can store a -1 here, or maybe you can store a new number here. Let's say आपको you don't want to store 9 anymore, you will store 12 here. All those things you can do, but my point is, this container, this 4 byte of space is going to be fixed there. You can't mess up with it. You can't delete it. You can't insert according to your will. है ना? Just let me take one example. You have an array like this. Okay, size 5 only. So you have something like this. Sorry, let me make it another way. 1, 2, 3, 4, 5. You have a 5 size array, and let's say the array contains 5, 8, 9, 2, and you don't have anything here. It's just empty. Okay. Now what you want is, you want to insert one element here at the beginning. Okay, let's say you want to insert 12 here. So what you want ultimately is, your array should look something like this: 12, 5, 8, 9, 2. But in order to practically achieve it, what you will have to do is, you will have to shift all these integers one place to the right. Are you getting this thing? If you want to store this 12 here at the first place, you will have to do these shifts, right? ये आपको समझ में आ रहा है? Is this point clear to you? So do you see, we don't have much of a flexibility in terms of inserting at a particular place, deleting a particular element, or yeah, searching is almost similar in both the data structures. I'll not go there, but yeah, you don't have the flexibility of adding to your will and deleting according to your will, right? Because these particular memory allocation, this particular memory allocation is fixed. Okay, you can't say that, okay, I have this block here, let me just move this block here. You can't go around and do this stuff randomly. So that is one constraint here. So insertion and deletion, you don't have much of a flexibility here, right? This kind of insertion will cost you O of n amount of time. I think you can realize it. If one shift operation is O of 1, you are making n such operations, so it is O of n time, right? So that's also one problem. So you don't have flexibility for inserting and deleting, right? So I'm just saying this: insertion at the middle is time consuming, right? It is time consuming. That's just it. Now let's talk about linked list. Let's get an idea about what a linked list is, and then we will see how linked list is overcoming these problems, right? So I'm assuming you have some basic idea about a linked list, but I will still start from scratch, okay, so that we are all on the same page. Linked list, as the name suggests, is a linked list. Okay, so what I mean by saying that is, you have list items, right? You have list items which are placed randomly in the memory, right? So if let's say this is memory location 1000, this can be memory location 1032. This can be memory location 1084. There is no constraint as such, right? So these list items are randomly located in your memory. What do I mean by saying linked list? These list items are linked together, okay, by some means, by some way that we will discuss in the next few minutes. But the point is, these list items are linked. They are not. What was the point in array? Array mein they were stored at the same memory location, one after the other, right? That way you were able to access. So if I say that you are supposed to access the array element 0, you will go to the first element, right, the base address. And if I randomly say you want to go to the array of 4, you will directly calculate which memory location you need to go to. So what you will do is you will take the base location, right, which is 1000, and then you will calculate that, okay, from this 1000 I need to go where, I need to skip 4 integers and I need to go to the fourth one. So some internal calculation like this would go on, that 4 into 4 bytes, because it is an integer array, these many bytes I need to skip. So that is a good property of array, that just by saying this, I want to access array of 4, what you can do is you can skip these 16 bytes and directly move to the location where you want to go. Why are you having this advantage? Because you know where the first element is stored. You know where the first element is stored, so you leave 4 integer spaces from there and you directly reach the fifth integer, right? So accessing elements is a very good property of array. It's a O of one time operation, right? So this thing, you in the backend, or you can say Java logic, it does not traverse through the whole array. It directly goes to the memory location where it is stored, right? But in, so that is the property of array, because they are stored side by side. So it is very easy for array to traverse. If you say fifth item, it will just go there. If you say 10th item, it will just go there. But in linked list, what happens is these items are not stored side by side. As you can see, these items are stored randomly in the memory, right? Maybe this is 2000. Maybe this is 1200. So these items are randomly located in the memory. So how do we keep track of all these items? By linking them with each other. Okay, so maybe what I will have is I will have this item linked to this item, then I will have this item linked to this item, then maybe I will have a link something like this, and then maybe I will have a link like this. Okay, so these various list items, I am trying to link them by some logic. Okay, so these are individual list items, right? So the entity or the storage unit that is storing your each list item, or you can say one list item, is called as a node of a linked list. Okay, so you can say that node is the building block of linked list, right? What you do, you have multiple nodes in a linked list. You have some way of linking those nodes together, and that way what you have in the final result is a linked list, is a linked list of nodes. Is this idea clear to you? Like chain, right? Time complexity, not worry about it as of now, we will discuss it later. We can use array list for insertion, and don't worry Vikrant, the idea is array list is a concept inside Java. Linked list however is a, you can say, classic database data structure, right? So we are just studying it from a more from a theoretical perspective, right? You are saying that use array list, but my question to you is, array list probably uses linked list as its logic, right? So I get where you are coming from, what you are thinking, but this is also a thought. So as of now, just see it as a theoretical topic, and then later on you will realize what all advantages it has. You know? Okay. Array list, don't worry about array list as of now. Just look at linked list. Linked list is a data structure that we are trying to build from scratch. Okay. Array list is a ready-made implementation inside Java. Okay, so the question is, what does array list use inside it at the backend logic, right? So that's one thing. But let's drop it all as of now. Okay, let's not deviate from the topic. Let's stick to linked list. Once we are clear with it, then we can tackle the doubts from here and there, right? If this intuition is clear to you, let's get to the point. Let's get directly to the point on how these nodes are connected, on how these links are created. Okay, so in order to do so, let me just directly tell you how a node looks like, right? Cool. So how a node looks like. So I think you must be having an idea about it. A node is having two pieces of information. Two information it has. One is the data, right? One is the data, and second piece of information that it has is link to the next node, right? So linked list is a special kind of data structure where you have access to the first list item, and then based on the first list item, it has an information about the next list item, using which you move to the next list item. That list item will also have information about the next list item. So in this way, you will keep on iterating your linked list, traversing your linked list. Okay. So each node has two pieces of information. That is the data. So data is what your all these things that you write here, right? Int value or maybe character value, whatever you want to do. In 99% of the cases, the linked list that we make is storing integer data, right? Because in our purpose, we use linked list not to actually store data for some logical implementation. We use linked lists to perform manipulations on it. In our journey for DSA, we will perform various operations on linked list, right? So what we are concerned with is the properties, or the, you can say, things that we can do with linked list, right? The manipulations on linked list. So int value is mostly you will be having an integer value only, right? Because we are more concerned with the working of linked list than what we are storing here, right? So integer value kind of thing you will have, character value, whatever you can have, right? One piece of data. And the second thing that you will have is link to the next node. Now talking about this linking part, okay, first part is I hope clear to all of us. Now talking about the link part, what we want is inside a node, we want a piece of information that stores information about the address, that stores information about address of the next node, right? So before I move on and explain it to you, one thing that I want you to observe is all these nodes are identical, meaning all these nodes have the same internal structure, right? What do we call a collection of similar structure objects? Or you can say it's not a good question. What is the source of origin for making these nodes? What is the kind of facility that we will use from Java? So just to, I'm not stretching it further because I'm not getting a good way of framing this question. So I will directly give you the answer of what I'm thinking, right? My point is, don't you guys think that we should make a class to represent both these pieces of information? One is the data and the other is the link to the next node, right? So what I meant to say was all these nodes are internally the same thing only, right? Nodes, they are defined in the same way. So if we want to store information about the address of the next node, do you think that storing, or you can say keeping, a reference variable of node type will solve our purpose? Are you getting this intuition? So what I'm thinking about as of now is, if I make something like this, class node, and I only want two information inside it, one is int value and the other information is node, and I want to store the reference for the next node, right? So reference of the type node, and then the variable name, I'm giving the variable name as next because this is the most intuitive name that you can find for storing the reference of the next node, right? So that's it. Are you comfortable if we make a structure like this? Because the information that this particular class indicates is, if I make a node object, or if I make an actual node which will occupy memory, have these items inside it, how will the node look like? The node will look something like this, right? So it will have some piece of information inside it, right? And then it will have some reference for the next node, right? It will have some reference for the next node which will store information about the whereabouts of the next node. Matlab, this particular reference variable will tell us कि जो नेक्स्ट लिस्ट आइटम है, जो ऐसा दिखने वाला नेक्स्ट नोड है, राइट, विच ऑल्सो हैज अ वैल एंड अ नेक्स्ट रेफरेंस वेरिएबल, ये हमें बताएगा कि ये वाला नोड कहां पर है, राइट. So this particular variable here will tell us where is the next node of this linked list. Are you comfortable with the idea now? Not related to recursion in any way. So what type of data can node store? Int, char, string, anything, Vibhuti. That's what I said, right? Data is, it's up to you. You want to store whatever you want to store, you can store anything inside it. But the point is, for our discussion on linked list, we are not really worried about the kind of data it stores. It can store anything, but we will generally see in almost 100% of the questions, you will have integer value kind of data being stored. Because what we are interested is in exploring the properties of linked list. What all things we can do with the linked list, right? We are not really concerned about storing data here. That's what I meant. ठीक है? Custom data type which stores address of the next node and data as well. Exactly. That's what a class is in general, right? What is the node? What is the node next store hexadecimal value? So basically, it's a reference variable, and yes, internally it's stored as a hexadecimal value, but we don't need to go there. Okay, what you need to understand is it just stores the information about the address of the next node. So when you access this particular variable of any node, the information that you want to get is अगला node कहाँ पे stored है? Where is the next node, right? So let me just close the chat. Are we creating a class inside a class? No, Kumar. No, Ritik. We are just creating a class to represent node, and I will tell you how we will create linked list using node. Right? If we change the class name, then do we need to change the name of data type which stores the? Yes, Chirag. Yes. Because what do I want? I want to store the reference of node type of a variable, na? Of nodes object. So if let's say for example you write just for an example, if you write let's say test here, class test, so you want to store the reference of this particular kind of item, so you will write test here. But the point is, it doesn't make sense, right? What you are actually creating is you are creating nodes. So that's why I'm just naming the class as node, and that way it is becoming very much clear and more intuitive, right? So I get your question, but this is why we are naming it as node only. Cool, right? So if this part is clear to us, let's talk about making a linked list, but only if this part is clear to us, right? So let me just open the chat again. So I think we don't need it. I can directly move forward. Okay, let me take one doubt from Pranshu. Yeah, Pranshu, go ahead.
सर एक क्वेश्चन है कि ये जो आपने नोड बनाया है नोड क्लास के अंदर ही, ये मतलब क्लास के अंदर क्लास हम बना रहे हैं या फिर ये किसी इंट या कैर या किसी टाइप का होगा ये नोड? ये कंफ्यूजन अभी भी दूर नहीं हुआ मेरा.
Don't worry. Just stay on unmute only. See, class node. Okay. Do you remember that these variables that we create are actually your object? Sorry, are actually your object variables?
Yes sir.
So what you want is you want to convey the information that whenever you make a node, there are two pieces of information that you want it. One is the data. इसमें तो आपको doubt भी नहीं है, right?
No sir, no.
This is the part where you are concerned about. So my point is, this is just a reference variable. Reference variable of which class? Of the class node. What does it mean? This second piece of information is going to store the value of reference variables of the node objects. ठीक है? Because what we want is inside every node we want two things. First is this value that you are clear with. The second piece of information that we want is using this next reference variable, we want to understand where is the next node of this particular linked list. Okay.
Okay sir.
So that's why I have named it as node next and not maybe integer next or string next or something like that. Because I want to store the reference of the next node only. Next what? Node. That's why. है ना? So that's why we will have something like this. So let me just this I was looking at from the previous batch. Anyways, so I have this class list node. Let me just name it as node only, right? Refactor, rename node. Okay. So this class I have named as node. What are the two pieces of information I have? Int val and node next. Okay. So whenever I create a node, there are two things that I am concerned with. First is the value that I want to put inside it, and the second is the address of the next node that I want to be placed there, right? So now we have our bricks. Okay, that is the building block of a linked list. We have to see how do we arrange these bricks together, or let's have a class called as linked list, which will tell us how to create a linked list, an actual linked list using these nodes that you just saw, right? So this item, as soon as you do node n1 is equal to new node, what you are actually doing is you are just generating bricks. Inside this linked list class, we will have certain functions, certain functionalities that we will define that will tell you how you are going to use these bricks or these nodes and actually construct a meaningful linked list. है ना? That's the idea that we have. So before I move on, let me just tell you the general representation of how we write a linked list. है ना? It's not a coding part. I'm just telling you how we represent it so that it becomes visually more intuitive for us while solving questions, right? So what I'm going to show next is very easy but very important. That is what I want you to do in your starting days of linked list. Whenever you solve a question, make a representation of that linked list on your paper, and then only start establishing the links. So linked list questions are all about manipulating these links. If you master that, there is no question of linked list that you cannot start solving. Okay, every question that you see, at least कुछ तो दिमाग चलना ही लगेगा आपका, if you are clear with this approach. Okay, so generally how you represent a linked list is, or the final product that we want is something like this. So let's say this is my linked list of 4 nodes. So what first thing that I want to explain to you is, first node is containing the reference for the second node in here. So this part generally it's a pictorial representation, but what this part refers to is the next reference variable wala part. This is the next reference variable wala part. And now what it is doing is it is storing the link for the next node. Similarly, this is storing the link for the next node. This is storing the link for the next node. Now first question, there will come a point when you want to end your linked list. This is that point, right? So what should we store in the next variable of your last node? In the next of your last node. That's the question. So it's pretty straightforward. Is there anything to the next of this node? Is it pointing to anywhere? The answer is no. It is not referring or pointing to any particular node. So what we do in such a case when we want to represent the fact that this is the last node, we store a null here. And null is generally in the pictorial representation, it's just represented by a forward slash like this, right? So what do we store in the next of the last node? Next is equal to null. Okay, so that's a property you can say of the last node. Also, this is very important thing, the next thing that I am going to say. Do you realize or do you agree with the fact that if we somehow have access to this node, if we have access to this node or the first node, we can traverse the whole linked list. How? You have access to this, let's say you call it, you call it your temp node, right? You have a reference variable of the node type which is pointing to this first node. So what you can do is you have two properties. You have temp.val, which will give you the value, and you have temp.next, which will give you the reference to this particular item, right? So I think it's pretty clear now. If you do like if you move temp to temp.next, what will happen is this reference will then be pointing to this particular one. So now that you are standing here, If you again do temp.next, you will have the power of accessing this particular item, right? And then you will have the power of accessing this particular item, so on and so forth. Is this part clear to you? That all we need in a linked list is the access to the first node, and then by doing .next we can keep accessing the next list items, right? I have opened the chat again, so you can answer yes or no. If you have a doubt, you can raise your hand in the meantime. I can take that up. Yeah, Kalpana, do you have a doubt? Okay, since it's temp.val or temp.next. So, okay. So, what is temp.val or temp.next? So, I'm assuming your name is Amber. So, the significance of writing temp.val or temp.next is, see, we made objects, right, in object-oriented programming. So, there is this node item. So, when I'm saying that I have a reference of the type node temp, and this temp is referring to the item, which is what? The first node. Temp is referring to the first node, right? So it's same as saying when you make items like this, student s1 is equal to new student. Do you remember? Then we used to do s1.id is equal to 5, s1.name is equal to whatever, let's say Amber only, right? We used to do things like this. So how could we do it? Because we had a reference to this newly constructed student object, we used to access the variables with the help of this reference. So what does this reference tell you? Where in the memory is this new object created? And s1.id means go to that particular location and access the id variable. Go to that particular location and access the name variable. Similarly, when you have access to temp, the first node, let's say, what you can do is you can access the value because it has value and next, right? And you can access the next variable also, just as you did with your student. And my next point was, once you have access to the temp.next, other information that you have is you have the address of this particular node as well. So now that you have the address of this particular node, you can do .next to get address of this one. Once you have address of this, you can do .next to get address of this one, right? That way you can keep traversing, है ना? temp.next.val करके वैल्यू को एक्सेस कर सकते हैं? बिल्कुल कर सकते हैं नहीं. temp.next prints the address. Yes, it's a reference. Will the node.next variable be used in each and every question and will be having the same name as class? Variable does not have the same name as class, Prasad. Coming to the reference type, saying writing it as node next, yes, it will always be having the same name. Why? Because we want it to refer to the same object ना. आप क्या चाहते हो? In this next variable, what do you want to point it to? Do you want to point it to a student, or do you want to point it to a node? Are you getting my point? You want to store a reference for a node in this particular variable. That's why you are saying node next. That means a reference variable of the type node, which will point to a node, right? That's the point. So having said that, this is how a linked list looks like. And now we will see how to actually construct this linked list or how to insert in a linked list, right? So this is how your linked list looks. And now we will see how to insert in a linked list, right? So let's get to it. Insertion, right? So insertion in a linked list, right? What we will do is, so just to make the concept clear to you, I am first assuming that we have a ready-made linked list and we just have to add one node. Okay, so what I'm assuming is you have a linked list that already looks like this. Okay, you have a linked list that looks like this, and now you want to insert a new value at the end. Okay, so the picture that you finally want is you want to have added a node here. Okay, you want something like this. You want to add a node here. This is what? This is a new node. this is the picture that you want. Okay, the current picture that you have is something like this, right? You have nothing here. Cool. So now you want to add a new node, and what you want to what you will actually pass is the information that you need to pass is value to be stored. So let's say the first value is 1, it has 8 here, it has 4 here, and the next value that you want to store is 6. So what you want is you want 6 to be stored inside a node and that node to be added to this linked list. That is what you want. So all you will do is first you will create a new node and have 6 stored inside it. So node n is equal to new node, and then you want, what do you want? By this line you have an empty box that has space for two variables. One is the integer value and one is the reference variable of the type node, right? It's the node next, or you can say it's the next variable, right? So now you have access to these two fields. What you will do is n dot val is equal to what? N dot val is equal to 6. So this will store 6 inside it, and n dot next is equal to null, because you want to store it at the end, right? And let me tell you something. Do you remember I told you in Java also gives you some default variables, right? So even if you don't assign any particular value to this null, to this next, you don't write this line, Java will automatically assign the value null to it, because all reference variables by default have the value null. अगर आप value, if you have not declared the value for this particular integer, then the default value would have been 0, right? Just like that, the default value for this variable is null only, right? So now after doing these things, what do you have? You have an item that looks something like this. 6 is stored here and then a null is stored here. Let me take this node and place it somewhere here. 6 is stored here and a null is stored here. What you actually want is you want to have a reference like this from the last node to the new node. That is what you want. Okay, so how will you do it? How will you do this reference? First, you only have access to the first node, right? And let me tell you one more theory point. I think you already know it probably. First node is called as the head node. So the reference to the first node is called as head. Okay, जो मैंने temp बोला था, that is actually in theory it's called as a head. So whenever you have a linked list, you will not be passed the whole list or anything. You will just be passed a reference head. Using this head, you can access this particular item, and using head.next, you can access this particular item. Then once you have reached here, you can access this. Once you have reached here, you can access this. Okay, so that's how linked list works. But let's go slowly and slowly. So my point is, once you have access to this particular node, what I want is, I want you to reach here somehow. Okay, I want you to reach here, but let's assume that that part is over. By magic, by some way that we will discuss later, I have already reached here. So what is the picture now? I have a reference variable temp that is telling me about this particular item. Now all I want is, I want to establish a reference, or you can say a connection or a link like this. So tell me, if I have reached here correctly, is it fine if I say temp dot next is equal to n? Because that way what will happen is, instead of storing a null here, this particular next variable will store the information about this newly created node, and virtually, or you can say pictorially, it will look something like this. Do you agree? So all we need to do is create a new node, right? Second thing that I did not explain, I just magically told you, go to the last node, Let's call the reference for that as temp, and then do this thing, temp dot next is equal to n, and this way you are done. That is all that you need to do. Is this portion clear to all of you? Let me allow you the permission to chat. Is this portion clear? Badhiya. Okay. So now that this is clear, I think we have discussed enough theory, right? Now we can go ahead and try to code for this, right? So if I come to this linked list class, I told you linked list is like your house, the actual end product. Node is like a brick. So I am going to construct the house here. I am going to talk about what is important from a linked list perspective, right? So linked list has nodes, that is clear to us, but what is the information, or you can say what is the one thing that we need to represent a particular linked list? The reference to the head node, right? Right. So let me declare a variable like this, head. What does it mean? It will store the reference to the first node okay? And then all we need to do is we just need to create a function called as add, or maybe insert, whatever you want to do. Let me just name it as insert. So void insert. What does it accept from the outside? You need to pass an integer here, right? That is the integer that you want to insert, or let's call it insert at end. Insert at the end of the linked list. What do you want to get here? You want to get the value val. Okay. So what do you do now? Create a new node, right? Create a new node. So node n is equal to new node n dot val is equal to val, and then what you want to do is n dot next is equal to null. But as I told you, this line will we don't need to write this line because the next variable of any particular node will by default be having null only, right? So I don't need to write this line now. Sorry, traverse. I need to traverse to the last node because I want to add my current node, or you can say my new node, at the end of the linked list. So I want to reach my last node. Okay, how will I reach that? So generally for traversal, I prefer creating a variable called as temp. Okay, you can use whatever you feel comfortable with, but how I want to do is do this one is node temp is equal to head. Okay, and then what I want is let's say while. So I want to keep the temp moving while something is happening. Okay, so while some condition that I will tell you later, what I want to do is I just want to move my temp to the next node. I want to keep moving it till temp reaches the last node, right? So temp is equal to temp dot next. This is one line which causes problem to a lot of people who are studying linked list for the first time. So let me explain this portion to you first. Temp is equal to temp dot next. Okay, so let me tell you what I mean by saying this. Okay, let's say I have a picture like this. This is my linked list. Okay, I'm not making a very big one. I just want to cover one point, right? So what I want to do here is, this is my head, right? From the information that I have, this is my head. What is the first step that I did? Temp is equal to head. Okay, what is meant by that? That now temp is also pointing to this particular node. Okay, and what is the value stored in the temp dot next? Temp dot next is actually the reference for this particular node. So if my temp is here, temp dot next is actually storing the reference for this particular node. What do I want to do? I want to keep moving to the next node, to the next node, to the next node till I reach the last node, right? So my question is, how will I make these jumps? How will I move my temp to the next node and then to the next node? So the point is, now temp is pointing to this particular one and temp.next stores this value. In order to make my temp point to this particular node, is it fine if I do something like this? Because temp.next is storing the value of this particular node. If I write this line, my temp will also be pointing to this particular node. And obviously this is no longer true. Now the temp.next will be pointing to the node next to it. But are you clear with this? If I write this line, how my traversal is happening? This is one very important point. Okay, so I'll just give you the permission to chat again, right? So head को भी आगे बढ़ा सकते हैं. Yes, we can. But generally, how I prefer it is, I want to preserve the head there only. Because in most of the questions, I told you, right? What is the information that is used to represent a linked list? Head. So I just don't want to mess with it. I want to preserve that variable where it is, right? And I only want to return what? I only want to, you can say, change what? A temporary variable that I have created for traversal purpose only. So that in any question that where I'm supposed to return the head of the list, we will have a lot of questions where we are supposed to return the head of the list. So for that reason, I'm not messing up with the head variable. I'm just making a new one, changing that. Head variable's value is still preserved. Okay, that's the very easy basic logic. There is no, nothing other than this to it, right? Anmol, yeah, go ahead. Anmol, yeah.
गुड इवनिंग सर. सर मैंने कई जगह देखा है कि while लूप के अंदर जैसे हम प्रिंट कर रहे होते हैं ना, तो टेम्प नॉट इक्वल टू नल यूज करते हैं, ठीक है. एंड जब हम अपेंड करते हैं या फ्रंट में लगाते हैं ना, तो हम ये चेक करते हैं कि या कोई और ऑपरेशन प्रिंट के अलावा टेम्प डॉट नेक्स्ट नॉट इक्वल टू नल करते हैं. तो ये दो चीजें मतलब कि मैंने ज्यादातर देखा है. ये इसका थोड़ा सा आप क्लियर करवा देना.
ठीक है, वेरी गुड. So what Anmol is asking is about the condition that we will write inside while. So let's come to it. So now that it's clear to all of us that temp is equal to temp.next is actually moving your pointer or your temp reference to the next and next node. Now comes the other part. Where do we stop? We can't keep doing this indefinitely. Temp is equal to temp.next. We can't do it infinite number of times. Where do we want to stop? That's my next question. Okay, so if you have a linked list like this, let's say this is the last node. So in theory, ultimately what I want to do is, I want to stop here. Okay, I want to stop here. So what I will say is, I will not say it, what I want is, ultimately I want my temp to come here and stop. Okay, so what I will do is, my temp is currently here. Then it will move to this one. Then it will move to this one. This is where I want it to stop, right? This is where I want it to stop. What is the property of this particular node that can make me stop this particular variable here only? So basically, what is special with this node? I'll tell you, if I am at this node, what's special is, next variable of this node is null. So what I say is, temp, while temp is not equal to, while temp dot next is not equal to null, while this is the case, I want to keep doing this temp is equal to temp dot next. As soon as this happens, as soon as temp dot next becomes equal to null, do I want to go any further? That's my question. Now that my temp variable is pointing to the last node correctly, this is the condition, right, where I need to stop. Temp dot next is equal to null. Do I need to move any further? No. I want to stop at this particular point. When I exit my while loop, I want temp variable to store a reference to this particular node. Is this point clear to all of us? Let me allow you the permission to chat again. Sorry. Yeah. Yeah, Deepansh, go ahead if you have a doubt. Okay, Prasad, can you unmute yourself? I will explain it again, but just so I can understand what your issue is. Prasad, let me ask you to unmute. Yeah, thank you. So, can you hear me, Prasad? Can you say something?
Sir, yes, sir.
Okay, so just stay on unmute only so that when the doubt is clear, I can like get it. So, what is the doubt? My point is, do you understand that I want to have access to this particular node?
Sir, sorry, sir, I couldn't get it.
So, my point is, do you understand that I want to stop at this particular position?
Yeah, I can get it.
This you are clear with.
Yes.
Now, the question is, how do we make it stop? Right?
Yeah.
So we are doing temp.next, temp is equal to temp.next, temp is equal to temp.next. So it's jumping from the one node to the next node to the next node, right? But when I come here, I want it to stop. So what is the condition here? See, this is the last node, and for the last node, the value stored in its next variable is going to be null, right? This part, are you clear with, Prasad?
Yes, sir, yes, sir.
This is clear to you? So as soon as temp dot next becomes null, I want to move out of the while loop. I don't want to do temp is equal to temp dot next anymore. Do you agree?
Yeah.
So the condition that I will write inside my while loop is tab tak karo jab tak temp dot next is not equal to null. So when you are here, temp dot next is not equal to null. When you are here, temp dot next is not equal to null. When you are here, okay, temp dot next is actually equal to null. So this condition becomes false. You will get out of the while loop where your temp is pointing to the last node. Is it clear?
Yeah, clear, sir. Clear.
Pakka?
Yeah.
Okay. Yeah, that's all that I wanted to say. Right. So having done this, we will also come to the next condition that Anmol was discussing. When do we use temp not equal to null? Here we are saying temp dot next is not equal to null, and you don't have to mug up the logic. Ratna nahi apne ko kuch. We will understand it logically. So this thing I didn't mug up before coming to the class. I came into the class. What was the problem statement? I want to stop as soon as my temp reaches here. So this is the condition. And next we will see where we can use temp is not equal to null, right? So let's get to it. So while temp dot next is not equal to null, temp is equal to temp dot next. So when you come out of this while loop, temp is now storing the reference to the last node. And now all you want to do is temp dot next is equal to n and return. Just return from here. It's a void function. You don't need to actually return or anything, but I'm just saying that return from here, right? Is this point now clear to you? Temp dot next is equal to n. Is this condition clear to all of us? Let me allow you the permission to chat. ठीक है? This is clear. Okay. Sushmita, one person is not clear, but can you quickly raise your hand so that I can address your doubt quickly, Sushmita, or anyone who is not clear with this? What if there is no node? Very good, Aryan. Very good. That is the condition that I am going to take next. Right? Very good. Anyone who has a doubt, so Rakesh, if you have a doubt, maybe you can tell me. Yeah, Rakesh. I can't hear you. I'll go next to Dipanshi. Yeah, Dipanshi. Okay, Aditya.
हेलो सर।
Yeah, go ahead.
सर मुझे यहाँ तक तो क्लियर है, लेकिन एक चीज़ में मुझे डाउट है कि जैसे आपने नेक्स्ट एक वेरिएबल यूज़ किया, नोड यूज़ किया है, तो
नेक्स्ट
हमने
वेरिएबल
ये
यूज किया और
नोड यूज़ किया है, नोड, तो ये हमने कहीं डिक्लेयर नहीं किया, हमने क्लास भी यूज़ किया है, तो वह लिंक्ड लिस्ट नाम का क्लास है।
ओके, देखो एक एक चीज छोटी सी है ना, पैकेज आपको याद है, पैकेज वाला कंसेप्ट, वी आर इन द सेम पैकेज
यस
ओनली,
सर।
सो वी कैन यूज दिस नोड क्लास इनसाइड ऑफ लिंक्ड लिस्ट आल्सो। तो अपने को कुछ अलग से डिक्लेयर नहीं करना, यहाँ पे डिक्लेयर कर दिया ना। सो लिंक्ड लिस्ट ऑलरेडी कैन एक्सेस, लिंक्ड लिस्ट हैज द परमिशन टू एक्सेस द नोड क्लास, राइट? तो आपको कुछ अलग से नहीं करना है, आप डायरेक्टली यू कैन स्टार्ट यूजिंग इट, नोड n इज इक्वल टू न्यू नोड लाइक दैट, राइट? सो दैट इज नॉट एन इशू। और आप क्या बोल रहे थे दूसरा, को क्या बोल रहे थे?
नहीं सर, बस क्लियर है, वो वेरिएबल में ही दिक्कत है जो हमने डिक्लेयर नहीं किया, जो यहाँ यूज़ कर रहे हैं।
Okay, now it's clear, na?
यस।
Okay, great. Cool. Then, yeah, Ashwini, go ahead. Ashwin, sorry.
सर मुझे समझ में आ गया, लेकिन जब मैं प्रोग्राम करता हूँ ना तो मुझे एरर ही आ रही है, मतलब एकदम प्रोग्राम करके बताओ कि
I understand. So that will happen. So for that only I am saying, for the first few days, or you can say, like for the whole discussion that we are having, make a linked list using pen and paper, and then perform the operations. In linked list, it is very common to get null pointer exception. So sometimes what we do is, it's very common that we write an incorrect condition here. Sometimes what we do is पूरा logic लिख लेंगे हम लोग inside the while loop. We will not write this one line. Temp is equal to temp dot next. So जब हम सोच रहे हैं logic, we are thinking it iteratively. Do it with this node, then do it with the next node, then do it with the next node. But when we are writing the logic, we forget this. So this happens a lot during linked list problems. So make a linked list using pen and paper. Then whatever code you have written, try to, you can say, dry run it on the linked list that you have made on using pen and paper. So follow that approach and it will be more clear to you, each time you are practicing. Baki, when you will come to class, you will have these discussions. If this is clear to you, your brain will then start adapting, start responding more to the questions that involves manipulating the links and all that stuff. So that will also happen. So one is from my side, other is from your side, that make it on the paper and then try to attempt it, right, at this stage. So ultimately it will become clear to you. That's how it happens with everyone. You know? Yeah, Deepanshi, go ahead, please. Yeah. Okay, I still can't hear you, so maybe you can type your doubt and we can take it there. Okay. Okay, cool then. So now what we want is this thing we have done. Okay, Aryan asked a very good question. His question is, you are saying that I want to add to the end of the linked list. That is only valid if you already have a linked list, right? What will you do if your linked list in itself is empty? My question is, how will you figure out if a given linked list is empty? All you can say is, if your head is equal to null, if your head is pointing to null, that means you don't have any particular first node, or you don't have any particular node. So what you will do is, if your head is pointing to null, what you will directly do is node n this. If your head, what you will do is and you can just return from here. Let me just write it inside this. First thing you will do this, and you can just return at this point, right? Is this clear? So when you are inserting and you have an empty linked list, the head will be pointing to null. all you will do is ये जो नया node आपने create कर लिया है, make your head point to this particular node, right? Because inserting at the end is same as inserting when the list is empty only. From this point onwards, you will insert the nodes after this particular head, and then after that node. That way you will keep doing it. Okay. So now the next thing that I want to do is, you have created a linked list in theory, right? So you have something that you can call as a linked list, but the problem is you don't have any way to print the linked list, right? So maybe what we can do next is we can create a function to print linked list. Right, print linked list. So what it accepts is, it accepts the head, or right, what we want to do is, while some condition, print the right. So sorry, what you want here is, let's not change the line. So temp.val, you want to keep printing the temp.val, and then you want to keep doing this, temp is equal to temp dot next. Okay, so see, what I want to do here is, I want to print the value, move to the next node, then I will come again, print the value, move to the next node, then I will come again, print the value, move to the next node. I want to keep doing this for the whole linked list. So listen carefully now. Okay, so let's say I have a linked list that looks like this. Okay, this is my linked list. Now what I want is, I want to print it, right? So first I did temp is equal to head. So my temp is actually pointing here, right? What did I say? Print temp dot val. Okay, so what will happen if, let's say, it has 6, 5, 8, something like this? When you print temp dot val, it will print 6. Then you say temp is equal to temp dot next. Okay, so basically your temp will now come here, right? This will happen. Agreed? Similarly, you want to print again, and then what you want your temp to move here. You want to print this also. Where do you want to stop? See, this is the difference between this problem and the previous problem. This time you don't want to stop here, right? When you are coming here, last time when you were inserting, you wanted your pointer to stop at this position. आप चाहते थे कि मेरा temp यहाँ पे रुक जाए, so that I can establish a link to the new node, right? But this time you don't want temp to stop here. When you are here, you want to print this value also. And then when you do temp dot next for the next time, what will happen? When you are at this node and you do temp is equal to temp dot next, what will happen? Temp will actually become equal to null. That is when you want to stop. So while temp is not equal to null, tell me if you are clear with this or not. Let me allow you to chat again. Yeah. Okay. Can the people who are saying no raise their hand once? Dharmendra and Rahul, right? One doubt. Sorry, Ranu. Yeah, Dharmendra, go ahead, please. Ask a doubt. Yeah. Dharmendra. Okay, then you have Ranu, right? Yeah, Anu, can you please share your concern? What's the doubt?
हेलो
Yeah, go ahead.
सर मेरा एक डाउट था जैसे क्लास नोट बनाते हैं एक बार प्लीज कोडिंग वाली स्लाइड पे चले जाओ
हाँ
हाँ जैसे इसमें आपने लाइन नंबर 6 में वो जो नोड क्लास नोड जो बनाया है और उसका जो ऑब्जेक्ट बनाया है नोड एन इक्वल टू न्यू नोड लाइन नंबर 6, तो उसमें हमने क्या किया था, उसकी एन डॉट वैल्यू से हमने वैल्यू असाइन करवाई थी। और कभी हम क्या करते हैं कि नोड एन इक्वल टू न्यू नोड और जो पैरामीटराइज कंस्ट्रक्टर रहता है उसी में हम वैल्यू असाइन करवाते हैं।
हाँ।
तो वो चीज मुझे कंफ्यूजन लग रही है कि उसमें हमको कंस्ट्रक्टर क्रिएट करना पड़ता है या मतलब कंस्ट्रक्टर नहीं क्रिएट करें तो भी हम ऑब्जेक्ट बना सकते हैं।
देखो, कंस्ट्रक्टर हमें क्रिएट करना पड़ेगा, राइट? कंस्ट्रक्टर हमें यहाँ से नहीं मिला है, सो बेसिकली द ओनली कंस्ट्रक्टर, आई टोल्ड यू राइट, जब तक हम कंस्ट्रक्टर डिक्लेयर नहीं कर रहे, हम लोग केवल इस तरीके से कर पाएंगे। दिस मेक्स अ कॉल टू द डिफॉल्ट कंस्ट्रक्टर जो जावा ने बना रखा है, राइट?
सर
बट
एक मतलब मैं नोड क्लास बनाऊं और मैं उसमें कंस्ट्रक्टर डिफाइन करके मतलब उसमें पैरामीटराइज कंस्ट्रक्टर डिफाइन कर दूं, तो मैं क्या ऐसे ऑब्जेक्ट करके कर सकती हूँ? तो मुझे
हाँ,
कंस्ट्रक्टर में ही वैल्यू असाइन करनी पड़ेगी।
यस यस यस, करेंगे अपन, अगला वही करने वाले हैं, है ना?
ओके ओके
वेरी गुड, सो वी विल डू इट। ये क्लियर है ना अपन प्रिंट कैसे कर रहे हैं?
ओके ओके क्लियर।
ओके गुड। ऑल्सो या go ahead, Raja, or what's your name? Yeah, Deepanshi, go ahead. Yeah.
Sir, if we have taken int val, like we are assuming that we will always store int values. What about the char values and string values?
You can store it, है ना? But the point is, why I said that we will mostly be using integer values, because see, in this two functions that we are trying here, does it matter whether we are storing an integer or a character? Insertion logic remains the same, printing logic remains the same. So that's my point. We are concerned about these logics, manipulating the linked list, right? Traversing the linked list, utilizing these links and all. बाकी क्या होगा आपके प्रिंट स्टेटमेंट में? आप फिर से temp.rally लिखोगे, instead of printing a integer, this time it will print a character or maybe a string, right? So that's up to you which data you want to store, but that is not going to affect our logic. That's what I said. That's why in general all the questions that you will
Sir,
see will have integers only. Yeah, go ahead.
You are saying that we can also store char values and string values in the linked list.
Anything, yeah.
Okay.
Yeah, yeah.
Sir, one more thing. Temp.next is equal to n. Why we have taken it at n? We are storing the n value, null character, na? We are assuming it is the last node.
So see, what I'm saying is, you have an already existing linked list, right? This is your already existing
Yes.
linked list. For example, अभी क्या है? Temp is storing reference to this one. You can say the older last node, because this is not going to be the last node any longer. क्यों? क्योंकि अब जो हमने नया नोड बनाया है n, that is going to come at the end, है ना?
Okay.
सो अब क्या होगा? इसके नेक्स्ट में मैं उस नए नोड का रेफरेंस स्टोर करवाना चाह रहा हूं। फॉर द नेक्स्ट ऑफ दिस आई वांट टू स्टोर द रेफरेंस ऑफ द न्यूली क्रिएटेड नोड, है ना?
Okay.
Okay, yeah, cool then. So coming back to what we were discussing about the print logic, so what I was saying was, what we want to keep doing is, if I am at a particular node, I want to print it and move to the next node, print it and move to the next node, print it and move to the next node. This time when I move to the next node, there is nothing that I can print the value for, because this time the temp has actually become equal to null, right? So let me try to explain to you what will happen if I say, while instead of writing temp not equal to null, if I write temp dot next not equal to null, let me tell you what will happen. As soon as you will come to the last node, as soon as you will come here, what will happen? At this point, temp dot next is equal to null. So what will happen? According to your while loop logic, you will get out of the while loop. You will never get the opportunity of printing this particular value. But because you want to print it and then move on, what will happen? If you print it and move on and make your temp go to the next value, what will temp store now? Temp will now store the value null. That is when you want to stop. So that's why I'm not saying temp.next is not equal to null. I am saying temp is not equal to null. So compare these two inputs. If you do it this way, you will not be printing the next, you will not be printing the value of the last node, because as soon as you get this, that is as soon as you reach the last node, you will get out of the while without printing that value. Okay, so that's why while temp is not equal to null, what you want to do is print the value and temp is equal to temp.next. That's it. That's all. Okay. So if I let's say if I create a main class, this is our right. So now what I want to do is I want to create a new linked list. Linked list L1 is equal to new linked list. Right. Now what I want is I have created an empty linked list. Okay. I want to add elements to this one. So what I will do is L1 dot insert at end the value 3. L1 dot insert at end the value 5. L1 dot insert at end the value 8. And L1 dot print. Okay. So what I'm expecting is if my code worked correctly, okay, I want to pass the head. So how will I pass the head? L1 dot head. Okay, so that's how I will pass the head. Anyways, so what will happen now is inserting 3. So that condition will come up where head is null. Create the new node, assign that particular node reference to the head. After that, we will keep assigning to the end. So after 3, we will have 5. After 5, we will have 8. So if I want to print it now, ideally I should get 3, 5, 8 as the output. Let's see what happens now. Okay, we are getting 0, 5, 8. Good, we are getting an error. Let's see what happened. Okay, 0, 5, 8 linked list. So first thing is this one, right? Creating an empty linked list. L1 dot insert and at end 3. So when we want to insert the value 3, see right in front of you, do you see the error? So I made the new node, but I did not assign the value before saying that if head is equal to null. That's why first value जो insert हुई है वो बिना node बिना value के ही हो गई. Very silly mistake, but a mistake is a mistake. Let me run it again. Three, 5, 8. Clear? Crystal clear. एकदम मतलब एकदम 24 कैरेट gold की तरह. Change Shubham. What I did was by mistake I added this particular piece of code before I wrote n.val is equal to val. So क्या हो गया ना, मैंने नया नोड बना के सीधा उसको हेड पे असाइन कर दिया without considering the value. That's why I got an error in the first case. Do while में कर सकते हैं print function को previous condition से. Okay. Yeah, you can do whatever you want. थोड़ा implementation देखना होगा, बाकी clear है. How to take user input? हाँ, good question. Let's take user input also. If we code I will share. So basically we had a document for OOP na. Similarly, I will create a lecture codes document for our module, for our batch specifically, and I will keep updating every piece of code there. So do not worry about it. It is already written here and I will share it there also. Right? So don't worry. By the end of the class, you will have it. Initially where the temp will point. So Rakesh, देखो ना आपने temp को कैसे करा है? No temp is equal to head. So where will the temp point? It will point to the head node, right? The first node, right? So let's do a quick dry run because some of you are asking for it, and let me ask again then if it's clear or not. L1 is equal to new linked list. So basically a new linked list has been created. This is the linked list class. An object for this has been created, right? So basically L1 is one linked list which is empty now, which will have only one variable. So there is only one object variable, head. So L1 is a linked list that has a head variable. That's it. Now what we want is we want to insert into L1. So we are going to call this function insert at end, and then we are passing the value val. Okay. So what we have here is I have an empty linked list now. L1 dot insert at end 3. At this point, the head is null. So see what will happen. You have created the new node, right? You have created the new node. And then what you are checking is you are checking this particular condition. What does it say? If this dot head, मतलब इस linked list का head null है. If this linked list is empty, then head is equal to n. जो empty linked list है उसके head को first node पे point करवा दो जो आप insert करना चाह रहे हो, and return. That's it. So first step में यही हुआ. You have empty head, or you can say you have null head, empty linked list. So first step में you have created a node, and now your head is pointing to this particular node. So let me show you the picture how it looks like at this point. At this point, it is looking something like this. This is your L1. Head is pointing to the only created node which is having the value 3 and a null here. This is your picture as of now. Okay, let's see what happens if I call this function L1 dot insert at end 5. So you go to this function, you come here, insert at end. You have created a new node, right? You have checked this condition. It's not true anymore because head is not null. So what do you have? Oh, sorry. You only have one thing now. You have a new node created which is having the value 5 in it and a value null here. Let's see what happens now. Okay. Now I need to traverse the last node to the last node, right? Temp is equal to head. So temp is pointing to this particular node. And I want to stop at the last node. This is the last node. Let's see if we stop here or not. Okay. While temp dot next is not equal to null, but at this very node only, temp dot next is actually equal to null. See, this is temp. Temp के next में क्या है? Null. So you will start. So you will stop at this point only, right? So at the first point only, when your temp is equal to null, or you can say when your temp dot next is equal to null, you will stop here. So when you get out of the while loop, your temp is actually pointing at this particular node. Let's see what happens now. Okay. Temp is equal to temp dot next. So basically temp is now storing the reference to the last node. Yes, correct. Temp dot next is equal to n return. Basically temp dot next is equal to n. This is your n, right? This is a new node that you created. Return. So now you have a linked list something like this. Tell me if it's correct or not. Is this what you wanted so far? So this is correct only, right? So far this is the picture. This is how it looks like. Similarly, at the next step, you will have a node like this. You will have temp here. Temp dot next is not null, so you will move temp is equal to temp dot next. Your temp will come here, right? This is no longer true anymore. Now at this point, temp dot next is equal to null, so you will move out of the while loop. Your temp is pointing here. What will you do? Temp dot next is equal to n and return. So basically establishment of this link and return. So finally your linked list looks something like this, right? And now you want to print it. So by the same logic, you will keep printing your linked list now 3, 5, 8 till you reach the end of your linked list, right? So is it clear to all of you now? Crystal clear. The matlab code you will have to take a look at because this is the first few days only. But is the logic clear? Okay? N is the reference, right? N is telling you where that particular object has been created. So it's like an address only. Okay? So temp dot next is by default null. By default null matlab? What I meant is if temp dot next is null, stop. When you are inserting. While you are printing, if temp dot next is null, it means we are at the last node. And we want to print this value also. So you will not say temp dot next is null. This time you will say if temp is null. Because when temp dot next is null, you still want to print it, na? You want to get inside the while loop, do a temp is equal to temp dot next. Then जब temp null पे point करने लगेगा, that means you have reached the end of linked list. So print function में the logic is different. Here the logic is little different, right? So now let's take user input. Sir, अब node खत्म हो गया है तो null आएगा. Yes, yes, Amber. Yeah. User input you want, right? User input let's take because most of you want that. Does Java not have all these functions defined? Shubham, it has that, but now that we are studying it from a theory point, we are using it, right? ये जो insert अपन कर रहे हैं, it's only for that one particular case कि अगर हमें कभी इंटरव्यू में पूछ लिया, so we should know all these things. Also, these kind of functions improve our understanding of linked list ना. आपको इंटरव्यू में क्या पूछेंगे? They will ask you questions on linked list. They might not ask you the same things, but when we study these things, our logic is getting clearer for linked list. Now, our visualization is getting better. So that's why these things are important. Practically, आपको ये functions कभी use नहीं करने पड़ेंगे. But the point is, once you understand linked list, ये functions बनाने में आपको कोई दिक्कत भी नहीं आएगी. At this point, I completely understand your point of view and mentality. But एक बार ये सब clear हो जाएगा तो इतना heavy नहीं लगेगा जितना अभी लग रहा होगा शायद, right? Let me share this one link with you. Okay, so now we are done with this. Now you want to take user input. Okay, so let's do that also. Let's say I will give you n integers and I want you to make a linked list out of it. ठीक है ना? So what I want is this. I will still do. Then int n is equal to, first let's declare a scanner object. System.in, is equal to. ठीक है? So we have scanner int n is equal to sc.next n, right? For loop है ना? And now what I want is L1 dot insert at end sc dot next n, right? Keep doing it for n integers and then print it. Okay, so these lines I am going to comment as of now because I want to accept user input now. Okay, so let's run this program. Let's see if we are going to get the correct thing or not. I want to insert 4 integers. Okay, now it's asking me those 4 integers. So I want 3, 7, 2, 8. Now I should get 3, 7, 2, 8 printed like this. Okay. Nothing fancy. I mean, nothing at all. This was very straightforward. So that's actually all you need to do for taking the user input. Is it clear? Straightforward only, है ना? Nothing heavy. ठीक है? This is what you will do in your AccuJob portal questions also, है ना? Is it necessary to print list to have the head argument? No, Aryan, very good question. No. Let's say I don't pass the head from here. Okay. Aryan is asking, do we really need to pass the head to the print linked list function? No. Let's say I don't pass the head. Okay. But because I am calling the print linked list on L1, you have the access of head. How? Instead of saying temp is equal to head, you don't have any head here. But if you carefully see in this class, you have a head variable defined here. So when you do the temp is equal to head, what it means is temp. You are calling print linked list function on L1 linked list. So when you do temp is equal to head, it's automatically going to take head for what? The current object or the current linked list, that is L1. So you don't really need to pass it. Okay. But that's just, one way of doing it. So that way also you can do it. This way also you have done it. Let me run it once again to demonstrate my point, right? So 12, 3, 4, 66, right? So you don't really need to pass the head because it's like passing a redundant information. It's already present there. You have access to the head, right? If you are, if you know which linked list you are calling it for, you know which head it's going to take. But I just gave it, like that only, because in general when you have a print function, you pass a head node to tell the print function which linked list you are talking about. In this case, we don't need to do it, right? So what does return do in linked-list.java? As it is returning nothing, so we can skip return. Yeah, Jyoti, we can skip return. You are right, but just for the sake of you can say logical clarity, I wrote that. Also, if you talk about this particular portion here, at this point we want to return at this stage only, because I don't want to go further. As my head was empty, my logic of insertion is done. So here I want to return only. So this return is important, but yeah, this return you can skip. Here I have already not written any return keyword. So this return statement is actually not important, right? I just wrote it randomly. There is no logic for it. So you are correct, it's not required. It's a void function. Yes. Krishna, I was thinking about the same thing. So we will again have to take a 3-hour session. But let me ask Lakshay about when we can take it and when it is possible. Okay, don't worry. So Umesh, your question, if you want to insert null as a value, the point is integer cannot have a null value, na? Integer ke liye you can't have a null value. However, if you are, let's say, storing a string, in that case आप null भी store कर सकते थे, not an issue. So data पे depend करेगा कि आप value क्या store कर रहे हो. Can you shift your terminal window to the right so we can see full max code? अच्छा ऐसे कर लो. Okay, cool then. So now we are clear with what? Insertion, printing, and user input. Let me tell you one more thing. So I forgot who asked this question, but she was inquiring about the constructors. She was saying that we are using constructors in OOP. It's a good practice to make so. So why are we not using constructors here? Use constructors. Okay. I just did not want to burden you with all the other aspects. So now that we are clear with the logic, let's create constructors. So it's a functionality of IntelliJ that I'm using here. I'm not going to code each and every constructor. So what I'm doing is generate constructor for both these variables. So what it will do is, I covered both the variables, right? Int and node, int and next, val and next, sorry. So it will make all the constructors, default constructor, a constructor accepting only value, a constructor accepting only next node, a constructor accepting both these arguments. So see, oh sorry, my bad. So I have selected both these values, so it made a constructor with both these values. So to generate another one, I will have to generate again. Sorry, I remembered incorrectly. Constructor, I want to create a constructor for integer value, and now I want to create a default constructor also. So generate constructor, select none. So this is a default constructor. Here what I want to do is, I don't want to do anything. Let's not do anything here. Here what I want to do is this dot val is val and this dot next is equal to null. Okay, something like this. And one related problem, what is the problem that we have? Okay, I don't think we will have that problem anymore. So let's try to, I'm commenting this portion, taking this portion back just to see if my code is working correctly or not. Is there some problem? Oh, sorry, I didn't comment this time. 358, right? So this is working correctly. So yeah, that related problem was an old thing. So related problem was because I created this constructor, did not create a default constructor, and because I'm making objects like this, na, see new node, I'm not passing any parameter here, so it was getting confused. ये constructor कहाँ से उठाया? आपने तो बनाया नहीं, है ना? So that was the error. But yeah, this is also one more thing that you can create constructors like this. If you only want to pass the value, you can pass it like this. If you let's say if you want to insert a node in between, so you will also specify which particular node it's going to contain as its next, है ना? So that's also something. So is the discussion so far clear, so that we can maybe talk about deletion of nodes, inserting at the middle, questions like that. Let me enable chat. Sorry. You can answer this question. I'll just drink some water. Yeah, Vaibhav. Go ahead. Okay, you have not raised hand. Vaibhav Gupta. Yeah. Please write all code in one file because we don't have IDE right now. Doing it from online compiler. Okay, no issues. So you can do this. Okay, आपको ये करना है ना आप ऐसे कर लेना उसको, ठीक है? Because we are getting error here, I will just rename this class. Or maybe let me just call it list node. इसको list node कर देता हूँ मैं. आपको आप node use कर रहे हो ना, यहाँ पे ऐसे node use करो, ठीक है? But there is one issue. एक सेकंड ना, there is one issue that you will get because I refactored it. जहाँ पे भी node use हो रहा था, list node use हो रहा है अभी. So what you can do in your cases, जो ये पूरी class है ना, as it is उठा के उसको except the public, place it in your other file outside linked list class. So it will work as it is, है ना? So let me just undo renaming and remove this class from here. Okay, so that we get back to where we were. Okay, cool. So someone was saying something. Vaibhav, yeah, go ahead.
Yes. So sir, I was asking like आपने ये लिखा है ना उसके अंदर इंसर्ट एट एंड के अंदर इफ हेड इज इक्वल टू नल, यानी कि हमारी लिस्ट जब स्टार्टिंग में एम्प्टी होती है उस केस के अंदर हम वो चेक कर रहे हैं. बट सर जब यहाँ पर हम L1 डॉट इंसर्ट एट एंड कर रहे हैं उससे पहले हमने लिंक लिस्ट L1 इज इक्वल टू न्यू लिंक लिस्ट बनाया है, तो कहने को तो लिस्ट एम्प्टी है बट मेरा हेड इज नॉट नल, तो वो कंडीशन चेक कैसे हो रही है?
हेड तो नल ही है. देखो L1 इज अ लिंक लिस्ट, ठीक है? उसके पास एक वेरिएबल है विच इज व्हाट, नोड हेड. बाय डिफॉल्ट इसकी वैल्यू क्या होगी? किसी भी डिफरेंस वेरिएबल की डिफॉल्ट वैल्यू क्या होती है? नल होती है ना.
ओके, गॉट इट.
इसलिए है ना, इसलिए. अच्छा, बिकॉज मोस्ट ऑफ यू रिक्वेस्टिंग टू सॉल्व द क्वेश्चन फ्रॉम पोर्टल, सो व्हाट आई विल डू इज लेट्स keep these delete insertion for some later class. Let me solve one question from the portal first, है ना? So I was planning to solve one, तो कर ही लेते हैं अपन, ठीक है? So there is this question, merge two sorted lists. Okay, that's a good quality question at this stage because we are beginners only. So let's solve that question. Merge two sorted linked lists, ठीक है? So that's the question. For me, it seems pretty straightforward. I will explain it to you. I will stop at the points where I feel you can have doubts. But फिर भी अगर आपको कुछ और भी डाउट हो तो पूछना, right? Because you may have it. अभी क्या है, merge two sorted linked lists. So let me go to that. I actually planned it for today, so I have it open. If I go to the question says, given two pointers to the heads of two sorted linked lists, merge them into a single sorted linked list. ठीक है ना? So they are saying they are giving you two sorted linked list. Now what you have to do is you have to basically merge those two sorted linked lists into one and pass that back to the question. Basically print it. In AccuraJob portal we need to print everything, right? So print that particular merged linked list. ठीक है ना? Format for input is as follows. First it will give you the size of the first linked list, then it will give you the first linked list, then it will give you the size of the second linked list, then it will give you the second linked list. Okay, I will only code the merge for this particular one, but I will show you, this is the working code that we have on the screen. I will show you how this particular chunk of code is working. Okay, so see, you have a class node which has int data, node next, and it has a constructor node int data, where data is data, next is null. Okay, so it has a straightforward node class. Then you have then you have a class linked list. All it is doing is it's making a function called as add. उसमें क्या कर रखा है इसने, इट्स जो अपना इंसर्ट एट द एंड फंक्शन था, दैट्स एग्जैक्टली व्हाट इट इज डूइंग, है ना. हेड इज इक्वल टू नल है तो रिटर्न कर दो, अदरवाइज करंट इज इक्वल टू हेड, while current dot next is not null, current is equal to current dot next is equal to new node. Same thing, add function is same as insert at end. ठीक है. So what it is doing is, I'm just telling you the non-logical part of the code, okay. And inside the main function, if you see this particular portion here, what we have done is scanner sc taken the first integer, right, taken the length of the first linked list L1 is equal to new linked list, same thing, I is equal to 0, I less than I plus plus, int x is equal to sc dot next int L1 dot add x. We don't even need to do this, ऐसे कर लो, ठीक है ना. So basically I'm just trying to make it as close to my code as possible, right. Similarly sc dot next int here also, right. So this is for first linked list, you are taking n is equal to this thing, all that stuff, and this is for the second linked list that you are doing all that stuff, right. This is for the second linked list. Now then what you are doing is you are calling the merge function that we will code, and then you are doing some other stuff. Are you clear with the setup of the question? Setup means all the parts that are not related to the logic directly. Merge ka logic we will write, but are you clear with the setup? Taking input, creating a linked list, everything. It's exactly the same as what we discussed here, right? Exactly the same, no difference whatsoever, right? 84th line, what is it doing? Linked list L2 is equal to new linked list, so it's creating another linked list, na. The question says that you have two linked lists, है ना. You have two linked lists, so you're creating those two linked lists. Basically in AccuJob portal we are not given anything, we have to construct everything, na. So from that perspective I'm saying, आपने L2 बनाया, आपने L1 बनाया, all these things you are making yourself, है ना. Amber, can you tell me what you want me to do a dry run for? Because all these things I've already explained, right? So dry run for what? Can you tell me? Yeah.
Hello, sir.
Yeah, go ahead.
सर ये ड्राई रन कर दिया सर, कोड थोड़ा सा लेंथी हो रहा है सर.
अरे कुछ लेंथी नहीं है, आपको ये समझाना जो अपन अभी डिस्कस कर रहे थे बिफोर दिस. यही तो है पूरा, देखो ना, देखो क्या कर रहा है वो. I'll explain you. Okay, stay on unmute only. What's your name? Amber what?
अंबर.
अच्छा, so it's correct only ना. AMBER अंबर. आसमान.
Q
क्या नाम है, नाम क्या है?
QAMBER अंबर.
अच्छा, okay. What does it mean?
Inspiration.
Okay, nice, great. So see, it has the same node class, it has the same linked list class. उसके अंदर it only has one function, that is adding the data. Adding data वाला आप पूरा logic देखो, it's same as this one that we have created now. This function here, insert at the end, new node बना रहा है. It is doing this, if head is null, return head, all that stuff. If head is not null, temp dot next is not null, तब तक ये सब करो, temp dot next is equal to end कर दो. All this stuff, it is the same thing that's happening here. It's just that function का नाम दूसरा है. देख रहे हो आप? Do you see this?
Yes sir, yes.
तो पूरा वही है आपकी, ये तो खत्म हो गई, ये पूरा लॉजिक खत्म हो गया. उसके बाद if you see here inside the main function, what you have done is, all you have done is आपने दो लिंक लिस्ट यूजर से इनपुट लिए बस. n is equal to sc dot next मतलब जो फर्स्ट लिंक लिस्ट है उसकी लेंथ, उसका क्या किया, n टाइम्स फॉर लूप चला के l1 डॉट ऐड नेक्स्ट इंटीजर. सिमिलरली सेकंड लिंक लिस्ट के लिए m ले लिया और m टाइम्स फॉर लूप चला के l2 डॉट ऐड दिस थिंग. आपने बस लिंक लिस्ट कंस्ट्रक्ट करी है. उसके बाद मैंने बोला जो भी मर्ज का लॉजिक है मैं बताऊंगा अभी, समझा ना.
Yes sir, yes.
हाँ, so it's exactly same as what we had earlier, है ना. Don't worry.
Sir, thank you sir.
Sure. Okay, cool then. Let me just a second. Okay, so let's talk about the logic of the question. Okay, I told you all that you can say boilerplate stuff so that we don't have to. Let me just remove this logic. I was actually solving it before the class, so just to make sure that it doesn't throw errors in between the class. So anyways, so you have two linked lists. You are supposed to merge those two linked lists and preserve the sorted order. For example, what the question means is 1, 2, 3 is one linked list, 3, 4 is another linked list. So question wants you to do 1, 2, 3. This is one linked list. 3, 4. This is second linked list. So this is your list 1. This is your list 2. And what question wants you to do is 1, 2, then 3 is there. Okay. Both the lists are individually sorted. But what you have is 1, 2 and 3 is basically you have 3 at both the places. So you can take any 3 and then you have 3. If you consider this 3, you will have this 3 after that, and then you have 4. To make it a little bit more interesting or more, you can say clear for the first example, let me take a separate case. 1, 2, 4, 3, 5. So what we have here is 1, 2. So in the merged linked list also, what you will have is, this is our head 1, right? This is our head 2. So what you will say is, this is your first element, right? From both the linked list. So now your responsibility is to find out which node to keep first. जो भी छोटा है उसको पहले ले लेंगे, right? So this node we will keep first in the linked list that we want to return, right? So what we will do here is, this particular node we will keep as our head. Do you agree? इसको अपन we will make this as our head, and let me just take a third reference. इसको मैं temp बोल रहा हूँ अभी, because this is where we have started our journey from. ये अपना head बन गया है, and to traverse further I have given it a temp variable. Keep following. If you have a doubt later, we will take it up, don't worry. Okay, so now what we have is, आपका L1 move कर जाएगा from here to here. This is one important thing. This is what I want you to understand carefully. Why? Because first node you have taken from it. Now you will move the second node, because एक तो ये है competition में, L2's first node, and the second thing is, because L1's first node was smaller, you will move to the next node to compare between the next node, that is this, and the first node of L2, because L2 का तो node पहले बड़ा था ना. So these are the two competitors that you have now. And because still the condition that you have here is L1 dot val is still greater than L2 dot val. Sorry, is still lesser than L2 dot val. Do you realize this? This is your L1. It is still lesser than 3. So what you will do here is temp dot next is equal to L1. Tell me, do you agree? Because L1 is lesser, you want to store this particular value as the reference. Do you agree? Temp dot next is equal to L1, and also to move it further, temp is equal to temp dot next. So what I want you to realize at this point is two things. First is the linked list, the new linked list that we are trying to create, we are traversing it through the variable temp. The other point is, I am not making new nodes. I am just rearranging the links in the already existing nodes. Is this clear to you? Let me enable the chat again. We will take as much time as needed. Okay. So if it's clear to you, very good. If it's not clear, please feel free to ask your doubt. Hai na? Okay, it's clear only. So let's get back to discussing it. Yeah, Umesh, go ahead, please.
Sir, the question says both the linked lists are sorted,
हाँ.
but it doesn't mention that in what order they are sorted.
अरे sorted मतलब when they don't say in which order, it's usually ascending only. छोटे से बड़ा ascending, increasing order.
If you want to have a logic for both the type of sorted list, then
सेम लॉजिक आप क्या कर लोगे, 4 to 1 हो जाएगा, 5 3 हो जाएगा. दिस टाइम व्हाट यू वांट इज यू वांट द बिगेस्ट एलिमेंट टू कम फर्स्ट, बिकॉज आपको डिसेंडिंग ऑर्डर चलाना है. सो क्या करोगे, L1.val is less than L2.val. So आप क्या करोगे इस बार, temp.next is equal to, ये चाहिए आपको, is equal to L2 कर दोगे. L2 is equal to L2.next, है ना, समझ रहे हो आप?
Yes, sir. Sir, one code for in ascending order, one code for descending order. And we have a logical code that works for both the orders.
Both the orders में तो no, because the point is type of sorting is determining what kind of links we are establishing here ना. अभी अपन ने 1 choose करें, whether we will choose 1 or 3 is depending on that factor only, no. So 2 separate logics we will have to have, one for ascending, one for descending, है ना, because condition ही बदल जाएगी ना पूरी. Are you getting it? I think you went back to mute. No worries. Okay, L1.val is less than L2.val. Temp is equal to, this thing you will do, you will also, so basically L1, this particular item has been taken care of. So what you will do is you will move to the next item of L1. ठीक है ना? Is this part clear to you? I mean, I already asked you, you said yes. So let me move on to another thing. Okay, there is one more thing that I want to tell you, which is like not directly related to this question, but this is an approach that we will, you can say, use a lot of times. Okay, this is an approach that we will use a lot of times. So my point is, the first time we will have to determine whether my temp variable is going to point here or here. Okay, and the first, you can say the first node where my temp variable points is actually going to act as the head also. So for the first time, आपकी responsibilities थोड़ी सी ज़्यादा हैं. Do you realize? First, you will have to make sure where your temp variable is going to point. The second thing that you have to make sure is you have to declare your head variable correctly. Okay. So these two things you are supposed to do. So I am writing a small code snippet. Tell me if you agree with that or not. Okay, a very small one, right? So first what you want to do is, so what we want to do is, एक temp iterator चला रहे हैं हम लोग temp reference variable करके, because we want that particular you can say reference variable to keep track of the new linked list that we are making. Also in the beginning we also have to declare the correct head variable also. That's one more thing that we have to do, right? So what we will do there is node head, node temp, right? So these two nodes we will have. So first thing that we will do is, if list1.val is less than list2.val, what is it that we will do inside it? We want temp, because temp is initially null only, right? Sorry. So what we want is temp should be equal to list1, also list1. Or before I do that, so basically, do you agree that my head should point to this particular node? Because I am comparing the first nodes from list1 and list2, I want the smaller node to act as my head of the final merged linked list. Do you agree with that part? So basically, do you agree if I say head, sorry, if I say head is equal to what? List1, and list1 is equal to list1.next. Same thing I can repeat for, I will write an else condition and I will write the opposite conditions there. Temp is equal to list2, head is equal to list2, and list1, sorry, list2 is equal to list2.next. So forget the code for a moment. Are you clear with the logic that I want to do? I'm just trying to set up the head variable correctly and the temp variable. So I'm just going to open chat for now. है ना? Okay. It seems like most of you got it, but yeah. Why list1 is equal to list1 dot next is needed. So RNC, the point is, when I say that temp is this node, head is this node, I mean to say that this particular node has been processed. No. So for the next time that I will consider it, I want to consider this node. Iska kaam ho gaya hai. This I have compared with this one, and now its job is done. Now I want to consider this node next. Right? What if both are same? So Ankit, in that case, it will not matter. So आप एक general condition लिखो greater than वाली when the nodes are equal to each other. In that case, it doesn't matter because let's say यहाँ पे 3 था, यहाँ पे भी 3 था, if you remember in the original example. So it doesn't matter आप यहाँ का 3 ले रहे हो कि यहाँ का 3 ले रहे हो. It's the same thing only, right? Do we need to reset the head each time? So Shivan, that's the point. No, this thing that I am doing, that will be done only one time outside the while loop. Okay. So this thing I will only do once. What if one list is empty? Then list.val. So that condition we will handle separately. Okay, Vibhuti. So in that case, let me do it right away. Okay. So this function, that's first point. Okay. So if list 2 is null, ये edge case मैंने पहले handle कर लिया. So when I reach this particular point, I mean ठीक है. So now I need to in, or you can say in sorted order. ठीक है. This is what I want to do. So my point was to make you guys realize that, sorry, for the first time when I'm doing it, all these 7-8 lines of code I will have to write. Do you understand the logic behind writing this? Aryan, to answer your question, we are not creating a new linked list. We are using the existing nodes and we are just reconnecting the links. Okay. So you guys are clear with why we are doing it. Now I am going to propose a way so that we don't have to write all these things, all these 7-8 lines of code, and I will have a generic solution that way. Okay. So what I'm going to do next is, see, just try to understand it. If it's not clear, just let me know. We will take as much time as needed. Okay, because this is a really important concept. I am creating a dummy node. I am creating a dummy node whose only job is to help me with my traversal. Now look at it carefully. Node dummy is equal to new node. I don't really want to give any value or anything because it's a dummy node. Okay, now I will say node temp. You realize why I was making temp? Because I wanted to, with the help of this, I wanted to traverse my linked list, right? So temp is equal to dummy. If you see this now, what I will do is I had to do temp is equal to list1 and stuff like that, right? But now I don't need to do it anymore. Now I can have a generic logic that I will have inside my while loop, and what I will do is I will just keep flowing with this temp. So what I will do is temp dot next is equal to list1 or list 2 depending on the logic. So I will keep moving my temp correctly. Also I will keep moving my list 1 also. List 1 is equal to list 1 dot next, or list 2 is equal to list 2 dot next, whichever is the logic, right? Whichever is needed by the logic for me to do, I will keep doing all these things. Do you realize the benefit of doing so? Because you have a dummy node that you created at the beginning, all your linked list is out after that only. While returning, you don't need to keep the track of it separately. You can simply return dummy dot next, because if you remember, that is where the first actual node started taking place from. That is where the first actual node was, you can say, linked to. Do you realize this thing? Yeah, Kumar, sorry, Ritik, we are going to continue this thing later only, but I just wanted to introduce this one concept to you guys. It's a little bit confusing, I agree. So I'm going to repeat it. Don't worry. It is confusing. Let me repeat it. Okay. Once we get hold of this concept, we will drop today's class. But let's understand. Try to understand this one once more. Okay. So what I want to say is, by writing, all of you are clear with this thing. Okay. By writing all these lines of code, we are getting two things. Okay. First, we are getting the correct, you can say the correct node for head variable, so that we can directly return this head at the end of the question. And the second thing that we are getting is where to start the temp from, है ना? अपन temp को list 1 पे assign करेंगे, temp को list 2 पे assign करेंगे. That's also something we are getting here. So we are getting the correct value of temp. Okay. Initially it was null only, right? Null, or maybe not defined properly. So then you were doing that logic to get the correct value of head and temp. The main reason why you were doing that thing was to get the correct value of head. Okay. Now, if I create a node and insert it before the first node of my merged list, will I have the access to head? मैं क्या कर रहा हूं? I am creating a dummy node, and why am I creating that dummy node for? आप देखो मैंने क्या किया, मैंने temp को dummy पे assign किया, and what is it that I am doing with temp? आप देख रहे हो ना, मैं temp dot next is equal to list 1, temp dot next is equal to list 1 या list 2. I am doing this based on whichever value is smaller, right? I am establishing those links. So first link क्या होगा? First link मेरे dummy node से जाएगा किस पे? Either list 1 or list 2 की value. So maybe it will go to somewhere like this, जो 1 value था, right? So temp is now pointing to this, right? Which was earlier list 1. And what is the remaining picture? And the remaining picture is like this. This is list 2, 3, 5. This is your dummy, right? This is your dummy, and this is your list 1 now. This is how the picture looks like as of now, right? So now what I will do is, let me demonstrate it from one step before, right? This is where my temp was, right? Now I will compare between list 1 and list 2, right? What will I do then? Because list 1 की value is smaller, I will just say temp dot next is equal to list 1. So this link will be established, and then I will say temp is equal to temp dot next, list 1 is equal to list 1 dot next. So what will I get there? Temp will come here, and list 1 will come here. By the same logic, what I will have next is list 1 and list 2 I will compare. List 1 is smaller. I will again say temp dot next is equal to list 1, and list 1 is equal to list 1 dot next, temp is equal to temp dot next. So basically I will establish this link. Sorry, this I want to let go of now. I will establish this link which was actually already there, and what I want to do now is, this is my temp and this is where my list 1 will come. right? Now list 1 and list 2 के बीच में comparison I am having. So list 2 wins this time because it's smaller. So this link I will have now. I will have this link. Temp.next is equal to list 2. List 2 is equal to list 2.next. Temp is equal to temp.next. So basically temp will come here. Temp will come here. And list 2 will come here. Again, list 1 and list 2. List 1 wins. So basically temp.next is equal to this one. Right? Temp.next is equal to this one. Right? This link will no longer be there. List 1 is equal to list 1.next. Temp is equal to temp.next. Right? So by that logic, there is nothing. So basically you have null here, right? So basically list 1 will come here. Temp will come here as temp will come here, right? Having said all this stuff, so basically now I will write some logic so that a link is established from this place to this place, right? And then we will be done with our logic. My point is, now you have something that looks like this. Okay, dummy, sorry. Then you have 1, 2, 3, 4, 5. My point was not to explain to you how this is getting constructed. My point was, do you realize that we have a dummy node that is just before the head of our answer? So we don't need to explicitly declare a head variable and write 6-7 separate lines of code to assign this head correctly. We don't need to do that. All we will do is, after our logic, we will just return dummy dot next, because that is where the actual linked list starts from. Okay, if it is clear, very good, congrats. If it is still not clear, we will firstly we will drop this approach. We will cover it normally by assigning the head variable at the first go and then writing an iterative condition. But if it is clear, then it's very good. Okay, so we can merge two linked lists and then try to sort it. No, Ankit, the point is, why do that if we have something easier to do, right? Isn't this like creating a new head and connecting the nodes from two linked lists that needs to be arranged? We are not creating a new head. We are using the existing nodes only. We are just rearranging between them, and by using this dummy variable, we are getting the hold of where that head is. Hai? So if we do dummy.insert at end using insert at end function, then we do not need temp and can return dummy directly instead of dummy.next. So I think you're getting confused, Vaibhav. Dummy is a node. Insert at end is a function that can be applied on a linked list. Okay, so dummy.insert at end is not a valid thing. Will we have 0 value in dummy node? Yes, Manvit, we will have 0 value in the dummy node, and the point is, it doesn't matter what value we are having there, right? So that's also one thing. So tomorrow we will complete this question. We will cover some other questions also, and then we will also see insert in middle and insert at the end. Insert at end ho gaya, and delete and deletion. My question from you is, before you guys drop from today's class, is the discussion clear now? Because I was having the feedback that you guys are a little bit unclear with the. I will have to allow you to chat again. So my bad. Just a second. So yeah, I was given the feedback that you are having some confusion in creating the linked list. So is that part clear to you now? I'm stopping the recording.